coming up, this guy. And we are being asked to find the local max, local min, and coordinates of saddle points of this function. And I'm going to begin by finding the partial derivative with respect to x. Then I'll find the partial derivative with respect to y, and essentially find all the critical numbers. And then we can do the test, although I probably won't do that part. Right, this fella here is going to be called f, and this guy here is going to be called g. So this is a product rule. If you differentiate 5 lots of x minus y with respect to x, you will get 5. And then you leave that guy alone. You leave first guy alone, and then you'll differentiate this with respect to x, which is essentially a chain rule. So it's e to the negative x squared minus y squared times the derivative of the inside function, which is negative 2x. I'm going to pull out e to the negative x squared minus y squared because they both share that as a common factor. This guy is nice. This guy is extremely ugly. Check I got that right. That and that gets you negative 10x times this. And then distribute this and have 5 minus 10x squared plus 10x y. Big bubble around it so I can find it again. Are we comfortable with that fella? If there's any mistakes that you see, I'm not saying there is, but if there is ones, tell me about it. Looks good as far as you can tell. Okay. Then we will, actually, I have enough room. I'll just do it here. We'll now find that guy. And he is also going to be a product rule. But this time, y is the variable, not x. So if you differentiate this fella with respect to y, you get negative 5. And you leave the other guy alone. Plus, leave the first guy alone. And differentiate this guy. And you will get e to the negative x squared minus y squared times the derivative of the inside function with respect to y, which gives me that. Now I'm going to pull out that guy again, and this time I have a negative 5, and that times that gets me negative 10y, x take away y. So I have this fella, I have a negative 5, I have a plus 10xy, and I have a plus 10y squared. Same question. Does that look okay?
Wouldn't we have minus 10xy? I'm getting my negatives mixed up here or not.
You are bang on. You're going to get a negative 10xy. And I am glad that you caught that, because the next line wouldn't work if you hadn't. So we know this guy and we know this guy. And we are going to find critical numbers. Critical numbers are values, right, coordinates x, y, where that guy is 0 and where that guy is 0, and both have to be true at the same time. It's no good you tell me a point where this is 0 but that's 20, right? They both have to be 0. Now, if I look at my two equations, the first one is basically this guy. And this has to be 0. That's basically that one. And if I write underneath it, we have this guy. And that's a -5. That's a -10 xy and a +10 y squared. And that has to equal 0. So far, so good. Now I'm going to do a couple of little things to make our life easy. Those terms.
Quick question. Isn't
Yes.
it supposed to be -10y squared? Or, oh no, you've rewrote it, never mind.
I've done it, but always good idea to keep track of me, right? I'm going to cancel them out. And the reasoning goes something like this. Two things multiplied together are going to be 0. This expression here can never be 0. Would you agree e to the power of negative anything is never 0, right? It's maybe 0.1, but it's never 0. So that leaves me with just these two expressions. And what I'm now going to do is add them, right? So those disappeared. You add them, you add them, you add them. And so I get 10 y squared, take away 10x squared equals 0. Are you comfortable about that? Do you see the 5 and the -5 kill each other off? And don't the 10xy and the -10xy kill each other off? So far, so good? Now, is there any kind of factoring you could do to make this side a little bit easier to deal with?
Factor out the 10.
Okay, good start. Is there anything more I could do?
We could divide both sides by 10. We'll get rid of it.
Okay, anything I can do, which is correct, is there anything I could do about the y squared minus x squared? Do you recognize that guy?
Isn't it y squared minus x squared times y squared plus x squared?
Almost.
Oh yeah, they're not squared, are they?
They're not squared anymore, but they started off squared. Which allows me now to get to a point where I can find x in terms of y. So if you take this guy, isn't y equals x is the conclusion. So as long as y is equal to x, won't this be 0? Right. Now, if you take this guy, won't y be equal to -x? So it looks like there are two distinct situations, right, that we need to work with. And each one of those is hopefully going to give me, eventually, some critical numbers. So I'm going to go back and write down this one again. Only I'm going to do y equals x. Well, if y is equal to x, then this becomes 5, take away 10x squared plus 10x squared equals 0. Interesting. Which gives me 5 equals 0, which is impossible. Agreed? Okay. Then I'm going to do y equals -x then. And that gets me 5, take away this guy, take away 10x squared equals 0. Would you agree? And combining them together, I get that. Isn't this much more promising? Doesn't this look like I might actually get something that's usable? Would it be okay to say 20x squared is 5? Would you be comfortable in saying that? 20x squared is 5. Wouldn't that then be the x squared is a quarter? And wouldn't that then get me plus or minus 1/2? Because both are true. Now, y is going to be the negative of whatever x is. So here's one of my answers. 1/2, comma, negative 1/2, and 1/2, or negative 1/2, comma, plus 1/2. So for any one of these x's, don't I just reverse it for the y? So 1/2 gets you an x, the negative 1/2 gets you the y. If the x is negative 1/2, the other guy is 1/2. Are we good so far? I've basically found the critical numbers. Right? Didn't get anything good out of that one, but I managed to get 2 out of this one. You might say, well, you only used the top one. What about using the bottom one? Can you trust me, if you use the bottom one, you just end up with the same 2 answers? Right? You just duplicate it, but I guess you should check it. And that's as far as I'm going to go with that one, because there's a lot of work left for you to deal with. Because aren't you now going to have to find the second derivative with x, the second derivative with y, and the second derivative xy, and then you're going to evaluate it at that number, and one of these is going to be true, and you're going to evaluate it with that number, and one of these is going to be true, and according to them, this one is a local max, at least in my question, and this one ends up being a local min. But you got a lot of work before you can prove that's true. Have you noticed how unique the solutions to these questions can be? The algebra is the killer. Finding the critical numbers. That's all, to my opinion, that's always going to be the hardest part. I mean, this test is long, but I mean, you can always do second derivatives and evaluate them at points, right? You can always do that. That's not too bad. But finding these solutions certainly is. So now we are going to, oh well, are we good? Can I move on from here? Okay. We are now going to look at questions of this type. Finding local max and mins. Or saddle points, I guess, just for completeness sake. Oh. Absolute maximums and absolute minimums under constraints. I just basically duplicated what we were doing earlier today. So you're going to get a function and there are going to be some constraints on it. And the type of things that you might get would be questions like this. What's the absolute maximum and minimum value, if it has any, of x squared plus y squared when y is equal to 2x? Or you might get one that says that guy, but the points lie in a triangle joining P, Q, and R. So you're not picking every single value in the universe. You're only choosing values on a triangle, or you're only choosing values on a straight line, or you're only choosing values on the circumference of a circle. There will be a constraint, and sometimes the constraints are themselves functions. So you might get something like this: x cubed minus 2xy plus y squared, subject to the constraint that x squared plus y squared must equal 1. So what we're trying to do here is imagine this is a surface. So can you imagine this is some, nice wavy surface doing its thing. if you're talking about a constraint, aren't you talking about a circle? And can you imagine if you took that circle and projected it up, wouldn't it make a distorted ellipse shape? Like, can you imagine it might look something like this, like a peanut. That guy there is the absolute max. And this guy here is the absolute min. And so we're talking about what is the biggest value of this expression, right? The highest up. And what's the lowest down, subject to a constraint. So you go on the floor. Can you imagine looking at the shape from above? Wouldn't you see a big red circle? Right, and that circle would come up and hit the surface, like someone, like an ant walking around the surface. Wouldn't there be a point on that surface that's higher than anywhere else, absolute max? And isn't going to be a point lower than everyone else? That's the absolute min. And that question, we call these constraints. So let's see if I can find a constraint. Okay. Question 11 is, what is the absolute maximum and minimum value that that function will take if the constraint, which they're calling D, is a triangle joining the points 0, 0 to 0, 2, and then to 8, 0. Now, the approach to these questions is quite different from what we've done earlier, right? We're not going to use this D guy, not in this question at least. First thing I typically do is I draw what that constraint looks like. And so you're going to go 0, 0, which is here. You're going to go 0, 2, which is here. And then you're going to go 8 zeros here. So basically, isn't your constraint a triangle? And I'm going to call this guy P, this corner Q, and this corner R. So how do we find absolute max and min of this function when you're only allowed to choose points on the edges of that triangle? That's essentially the puzzle. You take your shape, in this case, this fella here, and you break it into 3 pieces. I'm going to call that line 1. That's why all these colors are happening. This is going to be called line 2. And lastly, this one along the bottom is going to be called line 3. And for each one of these, you find the maximum and minimum value that that function can be. And then you look at the answers, and the biggest one of all 3 is the absolute max, and the smallest answer of all 3 is your absolute min. So let's start with the first one, the line L1. Well, what do I know about the line L1? Well, would you agree its x value is 0? And would you also agree that its y value is from 0 to 2? Are you comfortable about that describes this piece of the line? The x is always 0, and the y takes values from nothing to 2. So far, so good. Now what you do is you take the function that you're interested in, which is this one, and you use this information, whatever way it comes out, to change what this function looks like. Now, since x is always 0, would you agree that that's what you get if you replace x by 0? So on this line, won't this function just look like that guy? So far, so good. Now, what is the maximum and the minimum value that this is going to be? Well, 0 is its minimum, would you agree? And 2 is its maximum. And that's line L1 taking off, right? And then you move on, and I know this is slightly out of order, but there are kind of logic or a method to my madness. I'm going to do L3 next. Now, line L3, right, is this guy here, PR. And if I look at what's going on there, would you agree that the Y is 0 and the X takes values from 0 to 8? Are you happy that that describes PR? I then take my function that I'm interested in finding absolute max and mins of, which is this one. And I'm going to use the fact that Y equals 0. And if I use Y equals 0 here, don't you get basically X? Don't the other two get killed off? Now, what is the maximum and minimum value of this? Well, 0 is its minimum and 8 is its maximum. I don't know, I should put bubbles around these things. There we go. There we go. Now, if they were the only two constraints, right? If these were the only two I needed to look at, wouldn't you already be able to tell me that the absolute minimum is 0 and the absolute maximum is 8? You see, you could tell by looking at the combination. Now, we still have one more line to do, which is the green one, right? And of course, I kept the best till last. Line L2 has an equation, doesn't it? It's this equation of a line. And if you look at this line, would you agree that its slope is -1/4, rise over run? And would you also agree it passes through the y-axis at 2? Are you okay with me understanding that the equation of that line would be that, without me getting into finding the slope, y minus y1 equals mx minus x1, and 5 minutes later coming up with the same one? Are you comfortable about the shortcut equation of that line, right? If you know where it crosses the y-axis, which is 2, and you know the slope is -1/4, there's your equation. Now, same thing as before. We take the function that we're trying to find absolute max and min, which is this guy. Only this time, oh, I almost forgot. Doesn't this straight line only exist for values of x between 0 and 8, right? I don't use the entire line forever, right? Now, that means this guy becomes x. This guy becomes 2 take away 1/4 x, right? And this guy here becomes x times 2 take away 1/4 x. Are you comfortable with what I did there was replace the y by its expression in terms of x? Which in turn then becomes x plus 2 take away 1/4 x, take away 2x, take away 1/2 x squared. So far, so good. I should be able to make that a little bit prettier. So how about -1/2 x squared? Yeah, that's that guy. That's -1/4. So that's -5/4 x plus 2. Are we comfortable with that guy? If there's anything wrong, tell me now.
In the second line, is it supposed to be 1/2 x squared or 1/4 x squared?
Thank you. We good now? Right. Well, you might say, where's my max and min, right? I need a max and min. So this question becomes a little baby question, like a Calc 1 question. Suppose I have a function which is -1/4 x squared, -5/4 x plus 2, and I'm only going to use x's between 0 and 8. I would like to know what the minimum value of that is and what the maximum value of that is. Agreed? And I could certainly do it by algebra, but there's a quicker way. Any ideas how I could get that answer by using some technology? Any ideas who I'm going to use?
Well, you just said technology, so you could just graph it and find the turning point.
Pretty much, yes. Maybe I shouldn't have said technology, but that was the word that came out. You're right. Let me show you. I'm going to use Desmos, which is one of the things that you get in your Canvas, right, to help you, make your life easier. So here is Desmos. I'm going to do it a little bit different than a normal function. I'm going to do curly brackets, 0 less than or equal to x less than or equal to 8. That's how you tell Desmos only to do the graph in a range. And I want the range 0 to 8, otherwise I could pick up numbers that I can't use, like x equals 10, right? I don't want that. You then put a colon, and you don't type y equals, which I've discovered to my benefit. You just put the equation without the y equals part. For some reason, it doesn't like it. So there's, well, that's the wrong place anyway. On the top, on the side, there we go. Negative a quarter x squared, take away 5/4 x, good, and plus 2. Little curly bracket. Oh, would you look at that? It was actually easy. Because in this case, can you see that that point there is the biggest answer, right? The biggest value was 2. So the maximum value that I managed to get here is 2. And what was the minimum value? Well, the minimum value was right down here. So if I click on Desmos, it normally tells me it's at 8, -24. So in that range, right, only between 0 and 8, right, in that specific range, this expression has a minimum of -24 and a max of 2. So we are ready for the answer. The absolute maximum and the absolute minimum, right? Would you agree that the absolute maximum between all the choices that we've got was 8? And would you agree between the 3 things that we've got that the absolute minimum was -24, right? The other 2 were zeros. And there you go. The absolute maximum and minimum of this function, if you can only pick points on this triangle, ends up being a maximum of 8 and a minimum of -24. Are we comfortable with that process? Because it is a long process as well. And that's how you're going to tackle those questions where the restriction is straight lines. So maybe the next time it'll be a rectangle, right? Only use points on a rectangle. Actually, rectangles are easier, aren't they? Because x is 0, x is 7, y is 0, y is 10, right? They're easier to do, right? Or triangles, and that's fine. I hit the wrong button there. I'm trying to get back to my questions. Here we go. Now I'm going to show you another version of that question, but one you have to deal with algebraically a little bit different. Trying to find an example of that. Okay, this is question 13, or at least my version of it. The function that we're going to deal with is x squared plus 4y squared, take away 2x, take away 8y plus 1. And the region that we are restricting is that we can only use points in this region here. We're going to find the absolute max and the absolute minimum of this function inside this constraint. All right. Now I'm just making sure that we're talking about, yeah, we are. All right. Here's x, here's y. X is going to go from 0 to 2, and y is going to go from 0 to 3. So if we're thinking of what are we talking about, aren't we basically talking about this rectangular region? But we're also talking about the entire region. In other words, even points inside the rectangle as well. So that's an extra issue to deal with. Right? First one I'm going to do is let's just look at the 4 sides, and then we'll worry about inside after that, right? So I'm going to have to call them something. I'm going to quit calling them different colors. Are we cool with that one? So for each one of these fellas, we are going to set up how to describe each line, use it in here and get a minimum and a maximum. And then when we put the whole package together, including the inside points, we should be finished. So line L1, which is this line, has the features that x is 0 and that y only takes values from 0 to 3. So that's how I would describe L1. Now the function that we're dealing with, which is this guy, if you plug x equals 0 in, which is the most obvious one to use, you get 0, you get 4y squared, you get 0, you get negative 8y, and you get 1. And that becomes 4y squared minus 8y plus 1. So far, so good. Now, don't we have to find what the maximum and minimum value of this curve is, but only using values from 0 to 3? Which really means Desmos. So here goes. So I can't really, I don't know, can you put y's? I won't do y's. I know it's weird, but I'm going to do x's because it's just easier. Right, that's that guy. And the function that we're going to do it for is 4x squared minus 8x plus 1. And we're only interested in the values between 0 and 3. Would you agree that's the same problem as doing it with y's, right?
Mr. Robertson,
Yeah,
I think you put
I
a
did.
6 instead of a 8.
Yeah, I noticed that as well. I'm going to try some just out of curiosity. Nah, it doesn't like it when it's y's, right? So you're going to have to use x's. Right, in this picture here then, would you agree that the minimum number is, what's that guy there? -3, and the max is 13. So the minimum is -3, and the maximum is 13. And now I'm going to cut an awful lot of corners, and it's not going to be true, but you're going to pretend it's true. Couldn't I then do it to L2, to L3, and to L4? And wouldn't it look very similar and very time consuming, but we would get the answer, agreed? So that one we know is true. Can we pretend that I did it for L2? and the minimum was -5, and the maximum was 7, right? Just for argument's sake. And then I did it with L3, and I got the minimum of 2 and a maximum of 11. And then I did it for L4, and I got a minimum of -6 and a maximum of 3. Now, based on only these 4 guys, so if you were only allowed to pick points on the edge, right? Wouldn't you pick as your minimum the smallest out of all the choices, which is -6? And which number would you choose to be your maximum? Well, the biggest one out of the choice. Although I didn't do the other 3, do you get the idea of the process of how you would pick it, right? You would do it for line 2, you'd get an answer, line 3, you'd get an answer, line 4. Now, if you were being asked to only do the outside shape, that would be correct. But you are allowed in this question to pick points inside that rectangle. So what I now have to do is I go back to this question and I find the critical numbers, right? I find any point where the derivative with x and the derivative with y are both 0. Now I might get 2 or 3 points, but if I get a point that's up there and a point that's up there and one of them that's over here, don't you only use the critical number that's inside the region? Right. So that means we now have to go and do essentially a totally different piece of working. So find the critical numbers for that guy. So the partial derivative with respect to x is 2x, take away 2. Oh, that was easy. I'm surprised. Good. With respect to y, isn't it 8y, take away 8? Oh, this is going to be a lot quicker than I thought it was going to be. Now, if you make this 0 and you make this 0, aren't the answers just x equals 1 and y equals 1? Agree? Which means there's only one critical number, 1, 1. Is 1, 1 inside this rectangle? Yeah. Can we pretend it's there? So what I now do is I take the function, that's this one here, and I evaluate it at the only critical number that we have, essentially at the point 1, 1. And what do I get? I get 1 squared plus 4 lots of 1 squared, take away 2 lots of 1, take away 8 lots of 1, add 1. 1, 5, 3, 4, take away -4. Now, remember our 2 choices here? Does that number beat either of them? Is it lower than this one or is it bigger than that one? And the answer is no. So isn't this now our final answer? We're done. Now, can you pretend that was -40, right? Just for argument's sake. If that had been -40, wouldn't we change this one for now the number -40, right? Because this one counts as even lower than the other choices that we've got. So you're kind of looking at key places, right? To figure out essentially what's the absolute max and min of a function. We've got a lot to take in there. Hoping to see, if not happy faces, nodding faces. Is the process okay, even if it's time consuming? Right. So that was a second situation, a little bit more complicated than the first one. And so I'm now moving on, if I have time, which I should have. To do a third situation. And we're being asked to find the absolute max and min of this fella. Have you noticed that they make these equations polynomials because they're easy to work with? If these were anything really difficult, can you imagine how horrendous these questions would become, just practically speaking? So at least they did that to us. Now, here is D, the constraint. You can only pick points that have that property. I'm going to draw this guy. Would you agree this guy is everybody inside a circle whose radius is 4? So this question is now going to be split into 2 distinct pieces. The first step is I'm going to look for critical numbers. And I might find 3 or 4 of them, but I'm only interested in any critical numbers that are inside that circle. Matthew, what's your question?
Isn't that more like number 14?
Well, that's what 16 looks like. I'm going to scroll back and...
For me,
Good grief, it is. It is exactly 14. So
Okay.
I don't know. I think, is that coincidence? I'm checking 14. Well, whatever answer you get to 14, will you just write the same answer for 16 if it's the same question? I guess I should just rub one of them out. I think I'll do that. I'm going to kill 14 because I'm on 16, right? Because it's the same question. Right. So as I was saying, if you're going to do critical numbers here, aren't we only interested in any, because there might not be any, that are inside the circle? So here goes. If you can hear my dog at the background tell me that there's a leaf falling somewhere. There's 4x, 0, minus 4. Oh, isn't it nice when they give you guys that come out easy? And the partial derivative with respect to y then is what? 6y. Is that it? Huh. Well, I don't think I need to do any real heavy duty lifting here. Would you agree x equals 1 and that thing there? Right. Is 1, 0 inside my region of interest? Yeah. It's about there. Okay, let's find the value of the function at 1, 0. It's 2 lots of 1 squared plus 3 lots of 0 squared. Take away 4 lots of 1, take away 8. So that's 2, take away 12. I make that answer -10. So -10 is a candidate for the absolute max or absolute min, right? It's more likely an absolute min. Would you agree if it's probably going to work, it's going to be one of the smaller choices? So far, so good. Now, the second part. I'm only interested in finding out what the max and minimum values of this fella is equal to when you're on the edge of the circle, right? The boundary of the circle. Cool. So I am going to take this guy and I'm going to use it with this guy. And I'm going to try and see if there's any way that I can put them together and eliminate one of the 2 variables. So if you notice that the trick is to make the y disappear or make the x disappear and only have 1 variable. If I rearrange this guy and say that y squared can be called this, are you comfortable about why that is a good rearrangement? because if I put or replace y squared with 16 take away x squared in this particular function, because it works well, I will get 2x squareds plus 3 lots of this guy, take away 4x, take away 8. Do you see what I've now generated is just basically a quadratic equation? So let's see what that looks like. It's 2x squared plus 48, take away 3x squared, take away 4x, take away 8. I make that guy 5x squared, right? And I need some other things here, 5x squared.
Shouldn't it just be 1x squared? Just plain x squared?
Well, plain minus x squared.
Yeah, thank
And minus 4x and a plain plus 40. Would you agree? Now, do we have any constraints that we can put on x? Because if we don't, won't this curve go off forever? It may have a minimum, but it would allegedly have an absolute maximum, but it doesn't, does it? Look at the circle again. What are the constraints for x?
We're going from -4 to 4, right?
So won't that allow me to plug this into Desmos, but only use values from -44? And whatever the biggest one I've got, won't that be my candidate for absolute max, and the smallest one my candidate for absolute min? Does that make sense? So I'm now going to nip over to Desmos. This, if I do this right, we're pretty much perfect timing, which is unusual for me. Here goes. Fingers crossed. I want from x was what, -4 we decided, and the other side it's x equals 4, and the expression was -x squared minus 4x plus 40. Right, there we go. So the maximum value, hopefully I can zoom in that a little bit better. Right. Click on it. The maximum value is 44, would you agree? 44. And the minimum value is going to be, down in space, click on it. 8. Oh, okay. So the maximum value was 44. And the minimum value that we got here was 8. Put a big circle around that. And now we put all the information together and we should be done. Remember, this critical number gave us a value that the function could be. It could go to -10, right? And didn't this one say the minimum on the constraints was this and the maximum was that? When you put them together, then you should be able to come up with an absolute maximum and an absolute minimum. I'm pretty sure that we'll both agree with 44. What's the absolute minimum then? It's not 8, is it? Remember this guy?
Oh wait, unless I'm looking at the wrong thing here.
Remember this guy was -10? Is it not the absolute minimum value? What we're doing is picking candidates for the absolute max and min, right? And we're finding all different ways to find the places where it might happen. But once we know that, isn't the biggest answer you get anywhere going to be the absolute max? And the smallest answer that you can get anywhere is going to be your absolute min. This absolute minimum actually happens inside the circle, right? So if you pick a value of x inside here, that guy there, right, ends up giving you -10 for the function. And if you choose on the boundary of it, the maximum is 44. This one isn't working because that one beats it, right? That's smaller. Put your last name down.